Hi students, so till now in the continuity and differentiability chapter we have came across regarding the continuity, how we can say or when we can say the function is continuous, the conditions of continuity, all these things we have learned in the section continuity. While we are talking about differentiability, when we can differentiate the function, how many ways we can differentiate, the chain rule, the order of the derivatives, implicit functions, and parametric functions. So all these things are came across the chapter or in the concept of differentiability, and we have already gone through all these section. Today we are going with one of the fundamental result of the calculus, that is a Rolle's theorem and a mean value theorem. So today we are only going through the geometrical interpretation only. Here in this class 12th, the Rolle's theorem and mean value theorem, we are understanding the statement of the theorem through the geometrical interpretation only. So we are not going with the proof of this Rolle's theorem and mean value theorem. We are just understanding the Rolle's theorem and mean value theorem through the geometrical interpretation. So let us go with step by step. The first thing is a Rolle's theorem. So what is the statement of Rolle's theorem, or what the Rolle's theorem is saying is, if a function f is defined from a closed interval a comma b to the set of real numbers, from the closed interval a comma b to the set of real numbers, if a function is defined means, and if that function, that is, there are three conditions, that if this like function is defined and if that function is continuous, it is continuous on closed interval a comma b, and the same function f, it is differentiable, it is differentiable on open interval a comma b. That means the end points of a comma b, at those points the function f is not differentiable, and they are saying f of a should be equal to f of b. If these three conditions are satisfied by the function f means, then there is some c which is belonging to the not closed open interval a comma b. There belongs some real number c which is belonging to an open interval a comma b, such that f dash of c is equal to 0. So this is what the Rolle's theorem statement is saying. So remember guys, the statement of Rolle's theorem and the mean value theorem is very important, because they state the Rolle's theorem and verify whether the given function satisfies the Rolle's theorem. They ask the question in that manner, so that for that sake the statement of Rolle's theorem is very important. Now let us understand the statement of the Rolle's theorem step by step. They have defined a function f from an closed interval a comma b to the set of real numbers. They said that the function f is continuous on a comma b. So continuous means graphically we know that the function is continuous without break. If a function, if we draw like this type of function means, then we say that the function is continuous. Even this function is also a continuous function. So function is continuous on a comma b. And what they said next statement, f is differentiable on the open interval a comma b. A function f is differentiable means what does that implies? A function is differentiable means we can draw the tangent at every points on a comma b, on an interval a comma b, except at the end points. At the end points we are having a point, or the sharp edge we are having, so we can't draw the tangent at the end points. So remaining at the end points, at the rest of all the points we can draw the tangent. So differentiable means what? That only we can draw the tangent at every points on the curve. So if I consider like this type of curve, even though it is continuous, this curve does not satisfy the second condition, because at the sharp edges we can't draw the tangent at the sharp edges. So this type of graph is not going to satisfy the Rolle's theorem. So this type of graph is satisfying. I can't say sure, because there is another condition. They are saying that f of a should be equal to f of b. So let us draw the graph which is satisfying all the three conditions. So if I try to draw the graph which is satisfying all the three conditions, means a graph, it might be like this. You can see here, if I say this is our point A and this is our point B. So if this is A and this is B, a closed interval A comma B, you can see here function is continuous. You can see I draw this curve without lifting my pen, it is continuous. So I can draw the tangent at any point of this curve except at the end points, that is at the point A and at the point B I can't draw the curve. You can see that this point is nothing but, at this point is nothing but f of A and this point is nothing but our f of B. But you can see it clearly that both f of A is equal to f of B. So when they say that f of B should be equal to f of A, that means it is clear that the curve is taking an U-turn. That is what it implies. So you can see the graph, it might be in this manner, or it might be which is satisfying the graph which is satisfying the Rolle's theorem's three conditions. The graph, it might be even in this manner also, where if this is our point A and this is our point B, means what you can see here, this is our f of A and this is our f of B. You can see it clearly that both f of A and f of B is equal. So this is also satisfied, except at the end points we can't draw the tangent at these end points. Rest of all the points I can draw the tangent. Similarly, the graph, it might be like this. Suppose if this is our point A and this is our point B, means you can see here clearly f of A is at this point, f of B is also at this point, which is equal to 0. So both f of A is equal to f of B. At the end point, that means at the point A and B we can't draw the tangent, but at rest of all the points we can draw the tangent. So the graph which is satisfying the Rolle's theorem, obviously it takes the U-turn because of the condition, that is f of A is equal to f of B. So to bring this f of A is equal to the graph, it might be in any of these three conditions. Now what they are saying, there exists, if it is satisfying all the three conditions, means there exists some C which is belonging to A comma B such that f dash of C is equal to 0. So clearly we know that when by the graphical representation of studying the differentiability, when do we say the function is differentiable according to the graph? If we able to draw the tangent, so clearly if I draw the tangent to this curve at this point, say some any point some here, I'll call it like some P, means if I able to draw the slope of this curve at the point P, means we got this tangent. So the tangent, the slope of this tangent is nothing but the differentiability of this curve at the point P. This is what the graphical representation or the graphical meaning of differentiability is saying, which I have already explained while explaining the introduction of the differentiability. So since they are saying that f is differentiable on A comma B, means on an open interval A comma B, means we can able to draw the tangent at every point of the curve A comma B except at the end points of A comma B. So except at the end point, rest of all the points in the curve I am able to draw the tangent. So what is they are saying, there exists some C which is belonging to A comma B such that f dash of C is equal to 0, means what does that implies? So as I said, differentiability is nothing but the slope of the tangent of the curve at a given point. So that is nothing but the differentiability. So f dash of C is equal to 0 means that implies slope of the curve at the point C, slope of the curve at the point C is parallel to x-axis. So there exists some point, say C, which is belonging to the interval open interval a comma b such that at this point the slope of the curve or the tangent drawn to the curve is parallel to the x-axis. Obviously there exists such point. You can see here at this point, if I draw the tangent, means obviously this tangent is parallel to the x-axis. When any line is parallel to the x-axis means then slope of that line is equal to 0. The slope of that line is equal to 0 means what does that implies? That is f dash of c is equal to 0, because the slope of this, there exists some point say c which is belonging to a comma b. Clearly at this point c, the slope of the curve at the point C is a tangent which is parallel to the x-axis. So obviously in these type of curve, when Rolle's three statements, the curve which is satisfying the three statements of the curve, three statements of the Rolle's theorem, so this curve is having a one point, not only one point, there exists some point, it might be more than one. So there exists some points say C which is belonging to a comma b such that f dash of c is equal to 0. So f dash of c is nothing but slope of that curve. So that is nothing but the tangent drawn to that curve at a given point c. That tangent is parallel to the x-axis. Similarly, you can see here, this is a curve which is satisfying the three conditions of a Rolle's theorem. So there exists some point say c which is belonging to a comma b. So clearly at that point c, I can draw the tangent. So this tangent is nothing but the differentiability of this curve at the point C. So this tangent is parallel to x-axis. So slope of this line is equal to 0. So slope of this line is equal to 0 means what does that implies? The f dash of c is equal to 0. So f dash of c is nothing but the slope of the tangent of the line at a given point, that is equal to 0. So in these two type of curve you have got only one point say C which is belonging to a comma b, but you can see here in this, you can see that like that 2 points which is parallel to the x-axis. One is point say here which is I call it as C1, another point is say here which I call it as C2. So at the point C1 and C2 I can draw the tangent to the given curve so that the tangent is parallel to the x-axis. Here also if I draw the tangent at the point C2 means that tangent is parallel to the x-axis. So the statement itself, they have said for some C which is belonging to a comma b. So it might be more than one point which is belonging to the interval a comma b. So there exists some point. So that point, at that point, that f dash of c is equal to 0. So this is what the Rolle's theorem is saying. So you will get this theorem statement clearly into your mind when we solve some of the problem based upon this Rolle's theorem. So pause the video and note down all these points. So here there is a question. They have said that verify Rolle's theorem for the function y is equal to x square plus 2 where a and b is like this. So they are saying our a is minus 2 and b is 2. So within this interval we need to verify whether this curve or this function satisfies the Rolle's theorem or not. So by looking into the function itself, we can draw the graph of that curve. It is like this. So we know how the x square will be. So they said x square plus 2. So it will be like this. So they said from minus 2 to 2. Suppose if this one is minus 2 means then this will be 2. So from the interval minus 2 to 2. So this is the graph of the given function, that is y is equal to x square plus 2. So clearly this is the function or a graph of the, this is the graph of a given function within the interval minus 2 to 2. So what is the first statement of the Rolle's theorem? The three conditions should be satisfied. That is, first thing is f is a continuous. It should be continuous on closed interval a comma b. So clearly from minus 2 to 2 this function is clearly a continuous function. By looking into the graph itself I can say that this function is a continuous on the closed interval a comma b. Second, what is the statement of Rolle's theorem? That is f is differentiable on open interval a comma b. So on an open interval a comma b, so what is the differentiation? That is y dash or f dash. If I call that one, only has f of x is equal to x square plus 2, means f dash of x, what is the differentiation? It is 2x. So it is differentiable on an closed interval minus 2 comma 2. So I can draw the tangent at every point of this curve except at the end point of that curve, except at the end points. For rest of all the points I can draw the tangent, because it is a curve, it is not having any sharp edges. So through except at the end points, at every points I can draw the tangent. So this is a differentiable. What is the next thing they have said? That is f of a should be equal to f of b. So let us verify that one. What is a here? Here a was equal to minus 2 and b was equal to 2. So what is the function value of in f of, when it is f of a, it is nothing but minus 2 square plus 2, which is nothing but 4 plus 2, which is nothing but 6. Similarly f of 2, it is also equal to 2 square plus 2, 2 square it is 4 plus 2, it is 6. So clearly f of minus 2 is equal to f of 2. So clearly f of a is equal to f of b. So this curve is satisfying the three conditions of the Rolle's theorem. So they are saying if it is satisfying the three condition, means there exists some c which is belonging to open interval a comma b such that f dash of c is equal to 0. So we need to find this c which is belonging to a comma b, means within the open interval minus 2 to 2 I need to find that c which is belonging to this interval such that f dash of c is equal to 0. So what is our f dash of x here? F dash of x is equal to 2x. So what does f dash of c we are going to get? It is nothing but 2c. So if f dash of c is equal to 0, means what point we are going to get? It is nothing but value of c is equal to 0. If I equate f dash of c is equal to 0, means f dash of c is nothing but 2c here. So we are going to get the value of c is equal to 0 here. So 0 is a point which is belonging to the closed interval 2 comma, not closed, open interval minus 2 comma 2. So at this point 0 we can draw the tangent to this curve such that this tangent is parallel to the x-axis, or we can say it in the another way such that f dash of c is equal to 0. So at the point c is equal to 0, the tangent or the differentiability of this curve is equal to 0 at the point c is equal to 0. So this given function is satisfying the Rolle's theorem, and that point is where we are going to find that point. That point is nothing but c, and we got that point is equal to 0. This is how we are verifying the Rolle's theorem and solving the problem based upon the Rolle's theorem. So the next is mean value theorem. So we have just came across the Rolle's theorem. So this is what the Rolle's theorem is saying, that is f is a function which is continuous on a closed interval a comma b to r, means then if f is continuous on closed interval and f is differentiable on open interval a comma b, and f of a is equal to f of b, means for some c which is belonging to a comma b such that f dash of c is equal to 0. So this is what Rolle's theorem is saying. So mean value theorem, it is nothing but the extension of a Rolle's theorem. So what does mean value theorem is saying? Means suppose if f is a function from an closed interval a comma b to set of real numbers, and first thing, suppose f is continuous on closed interval a comma b, and the second is f is differentiable on open interval a comma b. Then for some c which is belonging to a comma b such that f dash of c is equal to f of b minus f of a divided by b minus a. So this is what they are saying. That means if a function is defined from the closed interval a comma b to r, it is continuous on closed interval a comma b and differentiable on open interval a comma b, and f of a is not equal to f of b. Suppose if f of a is equal to f of b means we can verify the thing with the Rolle's theorem. If f of a is not equal to f of b means then we can verify the thing with the mean value theorem. So here f of a is not equal to f of b in the mean value theorem, it is clear. So at that time for some c which is belonging to that closed interval a comma open interval a comma b, f dash of c is nothing but f of b minus f of a divided by b minus a. So now let us understand this mean value theorem through the graphical interpretation or representation. So the graph it might be like this, satisfying all the thing, or it might be like this. So you can see here the graph, this is our point say A, and say this is if I draw like this means if, and this is our point say B. Similarly here if this is our point A and this is our point B. So clearly this function this graph it is a continuous one because I draw this graph without any break, and it is differentiable. Since there is no sharp edges, we can draw the tangent at every point of this graph except at the end points. So they are saying for some c which is there exists some point c which is belonging to a comma b which is satisfying this thing. So now let us see it clearly what this is saying. So if this is a, and if this point is f of a, and if this point is nothing but f of b, means what is the coordinate of this point? Coordinate of this point is b comma f of b, and coordinate of this point is nothing but a comma f of a. Suppose if I join these two endpoints, I got a line segment which is joining the endpoints of the curve. So now if I ask what is the slope of the line segment, I am asking the slope of the line segment joining the end point of the curve. How we are going to find the slope of the curve? When the 2 points, we know the coordinate of these 2 points. When we know the coordinate of 2 points, how we are finding the slope of the curve? So we clearly know that how we are finding. Suppose if x1 and y1 and x2 y2 are given, how we are finding the slope of the curve? M is equal to y2 minus y1 divided by x2 minus x1. So this is how we are finding. Suppose if I say this one is x1 y1 and this one as x2 y2, how we are finding the slope of the line segment joining these two endpoints? So that slope is nothing but it is equal to f of b minus f of a divided by b minus a. So this is nothing but the slope of this line segment joining these two endpoints. Suppose if I draw a line parallel to this line, means we know that clearly the slope of two parallel lines are equal. So clearly if I draw the line segment here like this, so this line segment is parallel to this line this tangent which I have drawn here, this is parallel to the line segment joining the end point. So clearly the slope of these two lines are equal. So this is a tangent drawn to the given curve. So this is a tangent at a point, say some point C, which is belonging to the interval a comma b. So if this is a tangent to the given curve at the point C, means then the slope of this line segment or the slope of this tangent of a curve is nothing but the differentiability of this curve at the point C, right? So that's what we are saying, the slope of this line or the tangent drawn to this curve at the point C, so that is equal to the differentiability of the curve at the point C. The slope of that line is nothing but f of b minus f of a divided by b minus a. So this is what the mean value theorem is saying. Similarly, here also you can see here, I can draw the line segment. The coordinate of this point is f of a comma f of a, and it is b comma f of b. So if the slope of this line segment is nothing but f of b minus f of a divided by b minus a. So if I draw a line parallel to this line, means it is nothing but the slope of these two lines are equal. So this line segment is nothing but the tangent of this curve at the point, say C, which is belonging to the interval a comma b. So this is a tangent to this curve at a point C, means then the slope of this line segment is nothing but the differentiability of this curve at the point C. So what is the slope of this line segment at the point C? That is nothing but f of b minus f of a divided by b minus a. So this slope of the line segment at the point C is nothing but the differentiability of this curve at the point C. That is nothing but f dash of C. So here the differentiability or f dash of C is obtained by like this pattern. So here clearly, to understand all these concepts, you should be thorough with your last year's straight line chapter, where I have clearly explained regarding the slope, when the slope of the two lines are equal, when those two are parallel, at that time slopes are equal. So all these graphical idea which I have explained in the last year, all those things are very important to understand these things. Another thing is graphical idea of differentiability. That one I have explained this year while explaining the differentiability. If you didn't get, means go through that video and then follow this video, so that you can get clearly idea regarding what I am explaining here. So this is how the mean value theorem is going to be stated. So you can get clearly understood this concept when we are solving the problem based upon the mean value theorem or verifying the mean value theorem. So before going to that one, please note down what I am explained here right now. So here is the question, how we can verify the mean value theorem for the given function f of x is equal to x square on an closed interval 2, 4. So they have given the function f of x is equal to x square. So while explaining the continue itself, we have came across the graph of certain functions. So clearly the graph of x square is like this. But they have said that upon the interval 2, 4. So 2, 4 means clearly the graph, it might be lying from here to here. Suppose if I draw the graph of that one, means it will be like this. So if I call this one as equal to 2 and this point as equal to 4, means, so this is the graph of a given function, that is f of x is equal to x square. So clearly what are the conditions to be satisfied for the mean value theorem? Clearly the function is continuous. You can see it clearly while drawing the graph. It is continuous on closed interval 2, 4. The next condition of the mean value theorem, that is f is differentiable on open interval 2, 4. So clearly except at the end points, for rest of all the points I can draw the tangent. So this function is differentiable on open interval 2, 4. They are saying that f dash of c is equal to, for some c which is belonging to a, b, f dash of c is equal to f of b minus f of a divided by b minus a. So if this one is going to be satisfied, means we can find that c which is belonging to 2, 4. We need to find this c which is belonging to 2, 4, such that at this point we can draw the tangent, so that tangent is equal to like this. So now first let us find what is the value of f of b and f of a. So f of b, it is nothing but f of 4. F of 4 means clearly 4 square, it is equal to 16. And f of a, it is nothing but f of 2 square, which is equal to 4. So now what is our f dash of c? F dash of c is nothing but 16 minus 4 divided by b minus 4. It is nothing but 4 minus 2. So 16 minus 4, it is equal to 12. And 4 minus 2, it is 2. So it is nothing but f dash of c is equal to 6 here. But what we needed to find here, we needed to find here c. So to get c, clearly we know that f dash of c, how we can differentiate f dash of x here? See, clearly f dash of x is differentiability of f of x is 2x. So f dash of x is 2x. So f dash of c is nothing but 2c. But what we got our f dash of c has, it is equal to 6. So f dash of c is 2c, which is equal to 6. By substituting for the value of c, it is nothing but 6 by 2, which is equal to 3. So we got the value of c is equal to 3, which is lying somewhere inside this closed interval, open interval 2 comma 4. So at the point c is equal to 3, we can draw the tangent to this curve such that that tangent is equal to f of b minus f of a divided by b minus a. So through the mean value theorem, we found out at which point we can draw the tangent to this curve such that f dash of c is equal to f of b minus f of a divided by b minus a. This is how we are verifying the mean value theorem and getting the value for the c. So this is how the Rolle's theorem in the previous example and the mean value theorem in this example we have verified. So go through the explanation of Rolle's theorem as well as the mean value theorem clearly, so that understanding the statement of the theorem is very important, and even the statement of the theorem is also very important, because they might ask the question like, state mean value theorem and verify that the given function f of x is equal to x square on the interval 2 comma 4 is satisfying. So it might be, they might ask the question in that type also. If they ask state mean value theorem or Rolle's theorem, means you need to state those theorem like has they have explained in your NCERT textbook. So the statement of Rolle's theorem and mean value theorem are very important. So go through it. If you didn't get any of the point or you didn't understood, means please let me know. I will explain to you clearly once again. Thank you, students.